So in this workshop of vectors, we will be doing the numericals, and in last few lectures we already discussed a lot about vectors. So I think you all might be aware of all those things. So now it's the time to implement those things. So we'll be doing the numericals part. So let's start with the first one. Suppose the given things are like this. Vector A plus vector B is equal to something like this is given, and A square plus B square is equal to C square. This is also given. These two things are given, where you can say this A is magnitude of vector A, means vector A magnitude is A, and vector B magnitude is B, and vector C magnitude is C. So these all things are given. So like how we are going to find out the means like here we have to, you can say we have to find out what will be the angle between them. A and B. Okay. So by looking at this, what we like, suppose these are the two vectors, you can say A and this is B, you can say, and this is the angle theta between them. So what we have learned, like we saw parallelogram law, like if this is vector A, this is vector B, and this is the angle between them. So when we complete the parallelogram like this, so this is the resultant. And what resultant it is given here? It is given here C. Because A plus B is equal to C, it's given here. So instead of R, we can write it like C. Okay. So what this actually this was for A plus B, what we saw. Actually it's a parallelogram, we discussed it earlier. So like I told you at that time that this resultant C means this magnitude of C is equal to under root of A square plus B square plus 2AB cos theta. This I told you earlier. Okay. So what this is C. So you can make it like C is equal to under root of A square plus B square plus 2AB cos theta. Okay. Square it. A square plus B square plus 2AB cos theta. And we are given this thing also. So put it here. In case of A square plus B square, it will be equal to C square 2AB cos theta. This gets cancelled. So you have 2AB cos theta is equal to 0. Or we can say this is possible only when like there is one graph. I think you might be aware of this thing. This is the cosine graph. It's a cosine graph. It's like this. So this is minus pi by 2. This is origin, that's 0 part. The maximum value, this is 1. You can say it's 1. And it's here, it's minus 1. This is pi by 2. This peak point is at, it's 0, it's pi by 2, and this one is you can say it's pi. Then again it's pi by 2, pi by 2 pi, and then it's 3 pi by 2. Okay, so by the help of this you can see here that cos theta is 0 at what point? Either at pi by 2 or at 3 pi by 2. Means when this angle theta is equal to either pi by 2, like this, it's pi by 2, means pi by 2 what means? It means 90 degree. So it means 90 degree when A and B is 90 degree, or 3 pi by 2, you can say it's like this. This one is 3 pi by 2. This is 90 degree, but this is 3 pi by 2. Okay, this is vector A, this is vector B. So in both cases you can see that means this these two things are valid when the angle means theta is equal to 90 degree. You can say it's 90 degree, means A is perpendicular to B. Okay. So if these two conditions, means by the help of these given conditions, what we saw that A is perpendicular to B, means the angle dis between them is 90 degree. Okay. So if someone asks you that what is the angle between A and B, then we can say that A is perpendicular to B, or the angle between them is 90 degree. Okay. And remember this cos graph, cos theta graph. This is cos theta graph. There is sine graph also, but for the time being you should remember this one. When there is a need of sine graph, we will discuss that thing also. So this is the cosine graph. Remember that the peak point of this, you remember that the cos of 0 is 1. Cos 0 degree is 1. It's a, you can say this axis is uh, this axis is of degree or radian, you can say 90 degree is equal to pi radian. So this is the angle, you can say, and this is the value axis. So this is the angle axis, this is the value axis. Okay. So means you can determine like at cos 0 the value is 1, cos pi by 2 the value is 0. Again at cos pi the value is minus 1. Okay, the cos pi the value is minus 1. Cos 3 pi by 2 value is uh, 0. You can say here like cos minus pi by 2. If it's cos minus pi by 2, then the value is again 0. If it's cos minus pi, so this is the graph. Okay, leave it. Now let's move to another scenario, you can say. Suppose this is, you can say, some vector, you can say, whose magnitude is p. Okay, and here you can say again some vector whose magnitude is 2p. Here you can say again some vector. These all are perpendicular. Okay, these all are perpendicular whose magnitude is 3p. Again, you can say like this. This is like this. This is also perpendicular. So here you can say it's 4p. So what will be the resultant? What will be the resultant? Resultant will be this one. This one will be the resultant. So how we are going to calculate it? So like if this is 2p, this one is also 2p, and this one is also 2p. What will be this one? If it's 3p minus p, this one is also 2p. So what will be this one? It's perpendicular. Pythagoras theorem. This one will be 2p square under root of 2p square and 2p square means 2p root 2. This will be the magnitude of this, you can say, I initial point, and this is the final point. Okay, so if you can say, or the resultant magnitude of this resultant will be 2 root 2p. So in this way we can find out the resultant of this. Okay, let's move to another scenario. Like suppose if it is given like this, like it is given that you can say the magnitude of three vectors are given. Magnitude of three vectors are given, like 1, 2 and 4. So means we have to check whether it gives zero resultant or not. So how we are going to check it. Zero resultant comes in those scenarios when the you can say like I told you, like this is the vector A, this is vector B, and suppose the third vector is this one. So you can say initial and final points are same. So the magnitude of resultant is 0, you can say. So like here we are given these three magnitude of these three vectors. Let's consider vector 1 and vector 5. So suppose this is some vector, you can say this is vector 5. Vector means the magnitude of this vector is 5, and we are going to add this vector 1 like here. So this vector position can be here also, here also, here also, here also, here also. Means like in this circle, any position can be here. Like I told you, like if this is vector 5, 1 minute, this is one magnitude vector. So I told you like when we have to find the resultant of these two vectors. So what I told you was under root of, we can say 5 square plus 1 square plus 2 into 5 into 1 cos theta. And what will be the theta? Theta is this one, the angle between them. Okay. So you can say that when like I showed you the graph earlier, cos theta graph I showed you. This is 0 degree, this is minus pi by 2, this is pi by 2, and this is pi, and this is 3 pi by 2. One value minus one value. Okay. So the maximum, or you can say like when this vector is like here, vector means minimum magnitude, you can say 5, and this is what, 1. So minimum resultant value can be 4. Minimum resultant value can be 4. What would be the maximum resultant value? Like if this, instead of here, if this vector is here, like this one is 5 vector and this one is 1 vector. So here in this scenario, this will be 1. So here and what will be the resultant in this case? Resultant will be line joining this one. Don't get confused because I'm overwriting it. Like in this scenario, the resultant will be this one. So what will be the resultant? This is 5, this is 1 is equal to 6. So the minimum resultant magnitude is 4. Means if there is, if like if this vector is any position in this circle, you can say is in this semicircle, means it will be more than 4. Like if it's here, then it will be more than 4 and it will be less than 6. It will be less than 6 because everything will be measured from this point. From this point, the resultant is some here, so then this point. If it's here, then this point. So like minimum resultant magnitude is 4 and maximum resultant is what? This is you can say this is 5, this 5 minus 1. 5 minus 1 is equal to 4 and here what is 5 plus 1 is equal to 6. So this is minimum magnitude and this is maximum magnitude. This is minimum magnitude and this is maximum magnitude. Okay, so we have the third, like we considered 1 and 5 here. Rest of the thing is like 4 here. So when this vector is somewhere here, like when your this 2 1 magnitude vector is somewhere here, like you can say, so in that case, like this will be the resultant is 4. So this means this combination of three vectors can give 0 resultant. This combination of three vectors will give 0 resultant. Got it or not? I will repeat it again. Like here we considered, three things. Like we are given three vectors, so we took only these two vectors, 1 and 5. Sorry, it's 1, 2 and 4. We'll be considering 4. It's not. Yeah, it's fourth 4. So we will be considering this 4. 1 and 4. We are considering 1 and 4. So instead of this will be 1 minute. This will be 4 and this one is 1. So minimum will be 4 minus 1, that is 3, and maximum will be 4 plus 1, that is equal to 5. This one is 1, 4. Okay, this distance is 4 and this distance is 1. Mm, this distance is 1. Okay, this distance is 1, so 4 minus 1, that is equal to 3. So like minimum magnitude, like if this is the resultant vector, so like you can say for yeah, so minimum value is 3 and maximum value is 5. Okay, so this 2 2 does not lie, means you can say like if its minimum value is 3 and maximum value is 5 of resultant. So like 2, if it's 2 here means you cannot say that it will give 0 resultant. So because this 2 is not lying in this range, neither in 3 and 3 to 5 means it's not lying in this range 3 to 5. So this is not in equilibrium, means this will not give 0 resultant. If it was you can say 3, then it can give 0 resultant, but here you can say see that if it doesn't lie between the minimum range, minimum resultant vector value and maximum resultant vector value. So magnitude. So minimum value is 3, maximum value is 5. So and this one is 2. So it's less than that. So means there will be some resultant magnitude. So it means you can means this combination of vector will not have a zero resultant, you can say. Okay, this will not have a zero resultant, because for you can see here, like if these two vectors are here and if the third vector is like this, so initial and final points are same, so that will give a zero resultant value. But here you can say, like if this is the position for which the magnitude is minimum, but for that the resultant minimum value is 3 and the maximum value is 5. 4 plus 1 is 5. So this will not give zero resultant value, because our third vector is 2 of magnitude 2, but we need minimum 3. So in that case it will not give a zero resultant. Okay. Now suppose if we are given vectors like this, 2, like one magnitude is 2, another one is 3 and the third one is 5. We have to check whether they are in equilibrium or not. So again we have to find the maximum and minimum, let's consider this vector and you can say this vector. Okay, so like suppose this is vector 3, the magnitude of this second vector is 3 and suppose this one is 2. So in this circle it will be. So when this vector is here, you can say this 2 vector is here, so our resultant will be, this will be the resultant, you can say. So what will be the resultant? Minimum resultant, that will be 3 minus 2, that will be 3 minus 2 is equal to 1. This will be 3 minus 2 is equal to 1. And when this 2 vector is here, you can say, when those 2 vector is here, so it will be like this one is 3 and this one is 2, so this one will be 5. So here our maximum is resultant, this is resultant magnitude, maximum value, resultant magnitude, resultant magnitude. What will the resultant in this case? The resultant will be from this point to this point. Okay, this will be the resultant. So maximum resultant magnitude is 3 plus 2 is equal to 5. And here its minimum is 1 to resultant magnitude minimum value. So you can see here our third 5, 5 third vector magnitude lies between this 1 to 5, 1 to 5. So you can say it's in equilibrium. or you can say resultant is. Okay, so these three vectors are in equilibrium. Like if I am going to draw a neat diagram of this, like if this is vector of magnitude 3, this will be the second vector whose magnitude is 2. So what will be the resultant of this? No, now you can say the third vector. If the third vector is like this is 5 1. So it will be like this. All these three vectors are here. If someone asks you that for what angle between these two, like between 3 and 2, uh, 3 and 2 means the resultant is of these three vectors will be 0. So you can say like this is 3 vector, and like how we are considering the angle between these two vectors, this angle we are considering, and here what is the angle you can say between 3 and 2, it's 0. It's 0. Okay, so if someone asks you, if you are given any three vectors, and when someone asks you that like what would be the resultant, means we means if you are asked like this, that it means if these three combination of vectors can give a 0 resultant, so in this way we are going to check it. Okay, means we have to find out its maximum resultant vector maximum value and resultant vector minimum value. Consider any two vectors, means pick any two vectors out of three, and find out the like maximum resultant, maximum magnitude of resultant and minimum magnitude of resultant. If the third vector lies between uh, that range, then you can say that it can give 0 resultant. Okay, like suppose it is given what is given? That sum of magnitude of two forces is 18 Newton. 18 Newton. And magnitude of their resultant is 12 Newton. And it is also given like resultant makes 90 degree with smaller force. So like these three things are given. Like let us consider like our what is given, like this is, if suppose this is a big force, okay, and this is the smaller force, you can say it's F1, magnitude is F1, okay, magnitude is F1, force F1, and its magnitude is magnitude of F1, you can say like this, is F1, and F2, this is what is F2, this is F1, this is F2, magnitude of F2, magnitude of F2 is equal to F2. So this is another force. So I told you a parallelogram law, like, so what is being told, like this will be the resultant. This will be the, in case of parallelogram law, this will be the resultant. Like here it is given like the magnitude of F1 plus F2, like F1 plus F2, like here given the magnitude of two forces is 18 Newton. Okay, and the magnitude of the resultant, like this is the resultant, this is the resultant of these two forces is equal to 12 Newton. And it is also given resultant makes an angle 90 degree. 90 degree with a smaller force. This is the smaller force and its angle is 90 degree. Okay. So like suppose if what will be this one? This one is F1. This magnitude is F1, you can say. Because this force is F1 but this isn't the magnitude. This magnitude is F2. So you can say that like if this one is F2, then this one also is F2 because it's a parallelogram. This one is F2. And if this one angle is theta, this one is also theta. It's a parallelogram. This one is also theta. So here like resultant is given. Means so like this one is given as 12. Like this resultant magnitude is given as 12. So like we are aware of this F1, like I'm going to write like this is O, this is A, this is B. Triangle OAB, Pythagoras. OB resultant, OB square plus OA square is equal to AB square. What is given here, like resultant, OB resultant, this is resultant, magnitude of resultant is given 12. So we are going to write it 12 OB 12 square plus OA is F1 square. OA, what is OA? F1 square is equal to AB, what is AB? F2. This is F2 square. So like we are going to substitute from this equation to this equation, or you can write it like 12 square is equal to F2 square minus F1. In this case of F1, what we can write? 18 minus F2 na? 18 minus F1 square. So like as we know that a square minus b square is equal to a plus b into a minus b. Okay, so like we can write f2 plus 18 minus f2 and f2 plus minus, sorry, f2 minus 18 plus f2. So what it will become, here f2 gets cancelled. So like our equation will look like this, like 12 into 12 is equal to 18 into 2f2 minus 18. Okay, 6 to the 12, 6 3 is 18, 6 to the 12, and 3 4 the 12. You can write it like this: 8 8 is equal to 2f2 minus 18. 2 9 is 18, 2 4 is 8. f2 is equal to 13. Okay, what will be f1? F1 will be equal to 18 minus 13, that will be 5, that will be 5. So like from this given scenario, we got the magnitude of f1 and magnitude of f2. Okay, so the magnitude of f1 will be 5 and the magnitude of f2 will be 13. Okay, so in this type of cases or in this type of scenario, how we means this is the way by which we are going to tackle it. Okay, so tomorrow what I will be doing, that I will be discussing a three-dimensional part, a problem on three dimension. So like that's all for today. So I think tomorrow also we will be having a workshop. So we will be discussing more problems over it, and that's it. Thank you.